We're now going to look at the area of sectors using the formula that's given. So the formula that's given for the area of a sector is the area is equal to half r squared theta. I'm just going to talk a little bit about where that comes from. So if you consider a sector is part of a circle, so a sector would be like this, and we've got the angle there for the sector, so that would be theta. If we consider the full area of a circle, we know that the area of a circle is given by pi r squared. So that would mean that if we wanted the area of just a sector with the angle being 1 radian, so for a sector with theta equals 1 radian, then because there's 2 pi radians in a full circle, we just need to divide this by 2 pi. So the area for a sector with the angle being 1 radian would be pi r squared divided by 2 pi, which would give us, pi's cancelling, will give us r squared over 2. And then for any angle theta now, not just 1 radian, so for any theta, what we'd have to do is just multiply this by theta. And so we get the formula we've got on the left there, we'd get half r squared theta. So that's where the formula comes from for the area of a sector. So we're now going to apply it to this question here, 26. So we're given that the arc PQ, so this will be PQ, subtends an angle of 1.2 radians at the centre. So here's O, the centre of the circle, and by subtends it means this angle here, theta, is equal to 1.2. And we've got that the radius of the circle is 5 centimetres. So all we need to do is put those numbers into this formula, and we'll get that the area is equal to half times the radius squared, which is 5 squared, times 1.2. And so that's going to give us, when we work that out, that should actually give us 15 centimetres squared. So just put that in your calculator and that's what you'll get. Okay, so now we're going to look at this one. We've got example 27. So we've got to find the value of x in the following diagram. So what we're given is the angle of what you would call the minor sector, but we're actually given the area of the major sector, which is the other side, the reflex angle on this side. And what we've got to find is this radius x. So if we take our formula again, so we've got area is equal to half r squared theta, then what we can do is we can rearrange that because we're looking for the radius. So first of all, I'll multiply by 2. I'm just going to call area A. So I'll get 2A divided by the theta, so is equal to r squared. And then from that, I can just square root both sides. And I get that r is equal to square root of 2A over the angle theta. But what we've got to do is find the angle theta there, because this is the minor sector and we're interested in the major sector there. So because we know the angles in radians of a full circle is 2 pi, if we take pi by 12 away from 2 pi, we'll get the angle that we're interested in. So theta will equal 2 pi minus pi by 12. And so we're going to need to multiply top and bottom of the 2 pi. Imagine that could be 2 pi over 1. multiply top and bottom of that by 12, we'll get 24 pi over 12 minus pi by 12. Now we've got the same denominator, we can take it away. We get 23 pi over 12. We've also got that the area is 15 pi. So area, which is A, is 15 pi. So we can put all that into this rearranged formula. So we get that R is equal to square root of 2 times 15 pi all over 23 pi over 12. And actually we can tidy that up just before I put it all in the calculator, because we can cancel the pi's there. And so we've got R is equal to square root of 30 divided by 23 over 12. And if we work that out, then what we should get is 3.96 when we square root it. And not forgetting that that would be in centimetres, because we've got to have the units consistent throughout the question. So we can see we've got the area in centimetres squared there, and the radius is going to be given in centimetres as well. Now we're on to example 28. So here we're given this triangle ABC, and we're given that length AB is 9 centimetres, length BC along the bottom is 10, length CA is 5 centimetres. We're also told that there's a circle centre A, and that's of radius 3 centimetres. So that means that this distance here is 3 centimetres. So first of all, we've got to show that angle BAC, which means the angle here at A, with A being the centre letter, is 1.504 centimetres, radians, I should say. So for that, we're going to use the cosine rule, because we can see we've got 3 sides and we're looking for this angle here. So for a standard triangle, which we label ABC, which is coincidentally labelled the same as this one, we have to be very careful if it was labelled XYZ that we then rewrite the letters so they do apply to the formula. So the angles are the capitals, and then the lengths are the lowercase. And if we're looking for the angle at A, we could say that A is equal to cos minus 1 of B squared plus C squared minus A squared all over 2BC. So happily in this case the letters are the same, I say, but we might have to be a bit careful with that. So what we can say then is that A, in our case this angle here, or BAC as it's given in the question, is cos minus 1 of B squared, which is 5 squared, plus C squared, which is 9 squared, minus A squared, which is 10 squared, and then all over 2 times B, again the 5, times the 9, which is C. And if we make sure we're in radians mode as well, then what we will get is 1.504 radians. So make sure you're in radians mode when you're doing that, otherwise you'll get the wrong answer. Okay, so now we're on part B. So we've got to find the area in centimetres squared of sector APQ, which is this bit here. So we're going to apply the formula. So the area is equal to half r squared theta, using the theta that we've just found, the angle here. So all we're going to do is put that into the formula. We're going to get half, the radius is 3, as was given. So 3 squared times the 1.504. And so that will give us 6.768 centimetres squared. So that was part 1. Part 2, so we're going to find the area in centimetres squared of the shaded region now. So this is this bit here. So that's BPQC. So we're going to find that. So what we're going to need to do is find the full area of the triangle there. So I'll just write down what we're looking for first of all. So we're looking for BPQC. So the area of that is going to be the area of the full triangle. So area of ABC minus the area that we've just found. So minus the area of the sector there. So minus the 6.768 that we've just found. So what we're going to have to do for this area ABC is use the sine formula for area. And that is that it's equal to half AB sine C. So that's if we're looking at the angle at C. So that would be, if it's labelled like this, if we're looking for the angle at C, and this was A and B, and that would be A, that would be B. So if we're looking for the angle between two sides that we know, then that's how we'd apply it. So in our case, we know this angle, and we know length AC, and we know length AB. So there are A and B. And the angle that we know is the angle C. So the letters in the diagram don't always fit the letters in the formula, and we have to get them to fit that. So for our formula, this is our C. Okay, I'll cross it out so it's not confusing there. So what we end up with is half the A there, in our case, is 5 times the 9 times the sine of the angle that we've got there. Well, we've found that already. So we know that's 1.504. And again, making sure we're in radians. So if we just put all that in the calculator, and what we should get for that is 22.45 centimetres squared. So that's our area of the triangle. So that means BPQC is just a triangle area. So 22.45 minus the 6.768, and for that we get 15.682 centimetres squared. So now I'm going to look at the perimeter of that region. So perimeter BPQC. So for that, we've got 3 parts that we do actually know. So we know that bit, we know QC, we know BP there. Because we know that this length is 3, we know that one's going to be 6. And again, because this one's 3, the radius, we know that's going to be 2. And we know that this one is 10. And then we just need to find the arc QP. So the perimeter of that region is the 2 plus the 6 plus the 10 plus the arc length of QP. So we can use the formula for that one. And the formula for the arc length is that it's just r theta. So we've got, starting them up, we've got 18 plus r theta. And again, using our r that we found, r that we were given, and the theta that we found earlier on in the question, the 1.504. Just put them in the calculator, and we should get 22.5. And this one's a length because it's a perimeter, so that's going to be in centimeters.